If you ever wondered why your Saildrive and propeller sacrificial anodes deteriorate at such different rates, I might have an answer for you. Here's our Saildrive and folding propeller with a new set of anodes on the propeller hub. The Saildrive is a Volvo Penta MS25S, and this here is a Volvo 3-blade folding propeller. A week ago, when we got the boat out of the water, I immediately noticed that the three elements of the propeller anode here were used up completely. However, the anode attached to the Saildrive still look good. In fact, this is the same and I didn't replace it. Recently I've been reading about galvanic corrosion and stray currents, so I got a bit concerned that there might be something wrong. One would expect that these two sets of anodes here are connected electrically through the drivetrain, and if that is true, that they get used up at approximately the same rate. So, asking around, I got all kinds of possible explanations as to what could have caused this uneven rate of corrosion of the anodes. For example, a difference in anode material or paint between the Saildrive leg and the anode here that disrupts the electrical contact, making it then effectively useless. Another suggestion was that it might be just because of the mechanical loads due to the rotation of the anodes on the propeller shaft, so parts of them might just have broken off. Here on land I can't test the mechanical effects, but I can easily check if the anodes are in fact connected to each other electrically. To do this, we just take a multimeter and set it to measure resistance. Then we take our two probes and hold them each to one of the zincs. But as we can see here on the multimeter, we have a very high resistance between them, so they are effectively isolated from each other. We can check quite easy if the propeller anodes are properly connected to the propeller by just measuring between the anode and the prop itself at any point of the propeller. Just like this here, and with 1 ohm that looks okay, a very low resistance. Without disassembling the propeller and removing it, it is a bit more tricky to check the connection of the Saildrive anode to the Saildrive. The Saildrive is covered with anti-fouling, and below that the aluminium is coated, so we don't want to scratch that. But since I'm anyways doing an oil change for the Saildrive, I can remove the oil screw here and get access to a blank metal surface. I removed the oil beforehand, so that should not make too much of a mess. And if we measure here between these 2 points, lo and behold, the Saildrive anode is probably bonded to the Saildrive leg. To be honest, that completely stumped me at first. The whole Saildrive and propeller construction seems to be metallic, so it is hard to imagine that there is no electrical contact between the Saildrive leg and the propeller. But after some googling around and checking the documentation of the propeller and the Saildrive, I found out that it is supposed to be like that. Volvo even advertises that feature on their homepage. Apparently there is a rubber bushing in between here for shock absorption and to galvanically isolate the propeller from the Saildrive. So everything we measured before was correct, and it is installed as it is supposed to be. The difference in corrosion rates for the anodes makes sense now. If we check the anodic index on Wikipedia, that is a measure of how compatible two metals are with respect to corrosion, we find our anodes, which are made out of zinc, down here. The Saildrive leg is made of aluminium, and we get a difference of approximately minus 0.3 to minus 0.35 volts. The propeller and the shaft is made out of nibral, that is a nickel-bronze aluminium alloy. To keep it simple, we just check for the bronze, since nickel is even higher up. We find that the difference here is much bigger. It's a value between minus 0.8 to minus 0.85 volts. Since the difference here is much bigger, we can expect more corrosion to the more anodic material. Each of the anodes has a different objective. The one on the hub protects the propeller, and the one on the Saildrive protects the leg. Mystery solved. Everything is as it is supposed to be. So, what is now the moral of the story? Well, if you own a boat and you are not intimately familiar with all the systems, something that looks like a fault might actually be a feature. And sometimes reading up on the documentation can save you quite some time troubleshooting for a problem that is not. Lesson learned. I hope this video was helpful. If it was, feel free to like and consider subscribing. I will go inside now and warm myself up since it is around -8 degrees centigrade and I start to get a bit cold here. Thanks for watching.